Hello listeners, here is our new video about the ventilation rate, and hopefully you all are enjoying the videos, and our team is trying to give the more and more videos for your uh, architectural concept. And please like and share and subscribe our channels, so you will get notified when we will be with new videos. And today we will discuss about the concept of ventilation rate, which is generally asked in competitive exam. So first of all, ventilation rate. So ventilation rate is here total volume of air changed per hour divided by volume of room. So ventilation rate generally क्या होता है, एक जो भी हमारे पास स्पेस इंडोर स्पेस होता है, air change, how we do the air change, and what is the amount of air change required in different spaces, like in hospitals and bedroom, in drawing room, in other activities area. So air change होता है one room volume. One air change is equal to one room volume. If any room is having certain volume, that is that that denotes a air change. So this is also air change per hour, air change air change per hour, or cubic feet per minute. So the in this formula, ventilation rate is total volume of air changed per hour divided by volume of room. So if we know the volume of room, and uh, we we know the so if we know the total volume of air changed per hour and volume of room, then we can find out the air change in room, or it becomes the ventilation rate. So first we have to understand the heat loss during the process of ventilation. So air change is required for the process of ventilation. So heat loss during the process of ventilation, what is heat loss is equal to N into V into specific heat into dt. So here Q is equal to heat loss, this is in watt, N is equal to number of air change per hour, V is equal to room volume, then specific factor, then delta T, temperature difference between inside and outside. So this becomes the formula N into V into specific heat into dt. Some values are given and some we have to find out in any questions. And specific heat factor, if not given, then we can take it 0.34. And another formula for heat loss or heat flow rate is, if conduction process is there, then QC heat flow rate is equal to A into U into delta T. And what is A here? Surface area square meter. U is equal to transmittance value, and delta T is equal to temperature difference inside or outside. Then convection heat loss. So heat flow rate here, QV is equal to 1300 into V into delta T. So 1300 is equal to here volumetric specific heat of air, and it is in joule per cubic meter degree centigrade. Then ventilation rate in cubic meter per second, delta T, temperature difference. So these are the three formula here for air change or ventilation heat flow rate. First is Q is equal to NV specific heat dt, then A into U delta T, then 1300 into V into delta T. So again we will understand by this formula. Duct cross sectional area. So if the duct area is given and air speed is given, so we can find out the airflow rate in cubic meter per second. So generally in questions there are duct given and the area and speed is given. So heat flow rate we can find out. And if heat flow rate is given and air speed is given, then sometime they ask about the duct cross sectional area. So this formula is also important. So some notes are there, like 1055 joule is equal to 1 British thermal unit, then joule per second is equal to watt, 1 TR is equal to 3.5 kilowatt, 3517 watt, and 1 British thermal unit per hour is equal to 3.412 joule per second. So these values will be utilized in questions. So another formula for ventilation rate is equal to N into room volume divided by 3600. If the number of air change per hour is given and you know the room volume, then ventilation rate is we can find easily. So here 1 R is equal to 3600 seconds, so we divide by 3600 and it becomes in ventilation rate per hour. So ventilation rate is expressed in liter per second or cubic meter per second or in air change. So sometime in questions it is denoted in several form, like liter per second, cubic meter per second. So before in formula we heard U value of wall, or U value was there. So we have to understand what is U value also. So U value of wall is thermal transmittance. So rate of transfer of heat through a structure divided by the difference in temperature. So it becomes U value. Rate of transfer of heat through a structure divided by the difference in temperature. And the unit is watt per square meter Kelvin. And U value is denoted by 1 by R value and R total. And R we will study resistivity, total thermal resistance of the element here, and R total is resistant by the all elements. We add them and then find the U value of that composite structure. Again, R value is 1 divided by U value, and R value is equal to 1 by U value, and R value sometimes is thickness of material by thermal conductivity, and then we find the unit Kelvin square meter per watt. So these are reciprocal, so R value is equal to 1 U value and the unit goes like this. And thermal conductivity here is denoted by K value, and it is said as a K value. And time rate of steady state heat flow through a unit area of a material by a unit temperature gradient is known as K value, and it is not dependent on thickness. So in later videos we will learn about more for U value, R value, K value and C value. So now finally what we get the formula for ventilation rate liter per second, and we can form our formula for ventilation rate like this. In liter per second, air change rate into room volume into 1000 divided by 3600. So it becomes a ventilation rate. If air change rate is given, room volume is given, so we can find out the ventilation rate here. Air change rate into room volume in cubic meter into 1000 liter per cubic meter by 3600 second to hour, and this 1000 come for liter to cubic meter. And if we have to find out the air change rate, then we can change the formula, and air change rate become the ventilation rate liter per second into 3600 second to hour into 0.001 cubic meter second divided by room volume. So again, air change rate, ventilation rate into 3600 into 0.001 cubic meter per second by room volume, and ventilation rate again, air change rate into room volume cubic meter into 1000 by 3600. So always remember this formula for calculating the ventilation rate if given in liter per second, uh, like one air change, two air change, and sometimes in cubic feet per second or cubic feet is given, so we convert in liter, then convert room volume and find the ventilation rate. So we will do the numerical and then we will understand it fully. So uh, thank you for watching the video, and please subscribe the channel for the latest update and latest video, and if any corrections here you can notify us, and thank you.